Hello everyone. In this session, we are going to discuss about the relationships in the NoSQL and various kinds of data bases like environment, meaning that the NoSQL databases like schemaless and other databases. So let us go with that. So aggregates, they are useful for grouping the commonly accessed data, but sometimes they are related with the data. So in that case, we have to give the relationship between these data elements also. So how we can do that? Let us say, for example, in the previous example, customer and their orders. Some of the applications they need all orders when retrieving a customer, and they want to process the orders also separately. So in that case, it is better to go with the separate units of the data, uh, and we have to provide some link between these two. So in that case, a simple approach is we have to embedding a customer ID in the order reference and the secondary lookup in the customer details. That link we can provide, and with that link we can connect these two and we can retrieve the data easily. So that is a simple technique for the large amount of data, and in this case, and the approach it works, but it keeps the database unaware of the relationships. So it will work easily, but it doesn't know that there is a relation. It is not like the primary key, foreign key like relation, but it is there is a small reference only. Okay, so I think it is uh, um, it is useful for you. And now what we have to do is handling the relationships in the aggregation oriented databases, that is enhancing the relationship awareness in the SQL. So many NoSQL databases, they provide the ways to make the relationships explicit. There's a document stores. Document stores, they will allow the indexing. You can see that if you read a standard textbook or standard paper, they will give the indexing. While reading that, this related topic may be available somewhere. They will provide that in the brackets. There will be a number. That number, what that represents the relation, meaning that the corresponding content that will be available at the bottom of the page or at the end of the document. So that is the indexing. Indexing can be used. That is the document stores. They allow the indexing content with the aggregates for the query optimization. And key value stores, they support the metadata links. They will provide the metadata links. So this data is available here, this data is available here. Look like that the metadata links, they will maintain the relationships, and it can traverse easily. And some NoSQL databases, they will support the graph-like connections to for richer relationship modeling, so that we have one object. This object is related to this object. What is the relation that will be given with the edge? Okay, nodes and edges. So that is another thing in that. So we can go with the next one. That is the managing the multi-aggregate updates. The multi-aggregate updates, no SQL databases, they will treat the aggregate as the unit of atomicity, and meaning that the transactions are limited in a single aggregate. So the transactions, they cannot complete which we are using the single aggregate. So updating the multiple aggregates, they will require the manual consistency, meaning that uh, automatically there is no ACID rules providing, so that we have to provide the consistency. If you change something in one place, you have to change the same thing that should be affected in another place also. That relation you have to maintain. That is the complexity here. This complexity, it makes the aggregate oriented databases less efficient when many relationships requires the transactional consistency. So if you want to maintain the consistency, it will be more complex in this relationship aggregates. Okay, now complex relationships, they require the joins, so we can use this. And scalable aggregate aggregate based queries, we can use the NoSQL document store. And the frequent independent entry access, we can go for the key value. And hierarchical semi structured data, For that, we can go for the NoSQL document, and also we can go for the graph also. Okay, so these are the various things. And expanding the NoSQL beyond the aggregates, what is there beyond the aggregates? While NoSQL databases are often aggregate oriented, they are evolving the support more evidence advanced relationship management, that is a graph database. They are very much interesting. And hybrid NoSQL systems. They will combine the document, key value, and graph capabilities. Graph capabilities. So that is the better relationship handling is available. So graph databases. The graph databases, they will focus on the clustering and the aggregate oriented data structures. So that is the graph. They will be specialized for the interconnected data, and instead of large records and with simple connections, we can graph databases. They will store the small records with the complex interconnections. So you can see that here there is the you can say that here NoSQL distilled. It is having the relationship with the Pramod as the author, meaning that Pramod is the author for NoSQL distilled, and the database refactoring. This is also having the relation with the Pramod. It is also the author. And Martin, he is having the relation with the Pramod. He is the friend of Pramod. And like this, these are the various, you can represent a very big relationships with a simple connections and simple relations, so that it is the graph-based environment. In that, we can represent that it is having the nodes. The nodes represents the entities like people, books, product, like that, as we have seen here. All these are the various things. And the edges, they will represent what is the relation between those nodes. So Anna likes refactoring this book, and this is the author of this book is the Martin. So we can go with the different kinds of relations. Okay, use cases for the graph databases, social networks, and recommender systems, and also the fraud detection, network and IT operations. All these are the various use cases for the graph databases, and advantages over the relational databases. That is the optimize the queries for the relational traversal, and making them faster. It will speed up that, and shift processing effort, and it is having the efforts from the query time to insert the time, and benefiting the read heavy loads, read heavy workloads, so that, and it rely on the indexes for starting points, but prioritize the relationship based on the navigation. So all these are the various advantages over the relational databases. So it is very easy. And challenges and trade-offs. These are the various challenges for the graph databases. So in this, the typically it has to operate on a single server rather than the distributed clusters. Graph processing, so it requires the ACID transactions covering multiple nodes and edges. For the consistency, it requires this, and it offers the strong relationship management between the entities, but it may not scale as easy in some NoSQL solutions. So it is not an easy task to maintain the relations, these many number of relations. Schema-less databases is another concept here. For the schema-less databases, it is a common feature of NoSQL, and it is they're the schema-less. And relational databases, what is the comparison with the relational database? It requires a predefined schema relational database, and it is having the data must be conform to the structure before storage. So it has to follow the structure of the data, and the schema changes can be complex, and it requires the migrations. All these are required. And in the NoSQL databases, it allows the data storage without a predefined schema, and it supports the dynamic and evolving the data structures, and facilitate the many modifications without complex migrations and all this. So these are the various things about the relationships and various database structures in the NoSQL concepts.